Hi everybody, it's a pleasure to present you today this video. And in this video I will present a talk that I've done in the DGP meeting and also in the EXA 59 in Spain. And this talk speaks about what I've done during these last 2 years in Angers in France during my postdoc. I hope you will like it, so let's begin. Hello everybody, it's a real pleasure to be here today. I'm David Singer and I'm working in Angers in France, and today I will speak about the results that I obtained during my 2 years of postdoc there about biomonitoring of the intertidal zone using Foraminifera eDNA Metabarcoding. So, just a few words about the background. Estuaries are the ecotone where aquatic ecosystems, the ocean and rivers, interact with terrestrial ecosystem. We can see that there is a lot of natural stressors from the aquatic part, the tides and salinity, but also from the terrestrial part, from the nutrient input and flood. And in addition to this natural stressor, you will get some anthropogenic stressors, that is the pollution, aquaculture, erosion, and agricultures. And what we expect with biomonitoring is to monitor this anthropogenic stress. The estuaries will provide different ecological services like nursery, fish, birds, urbanization, aquaculture, tourism. There is an important role for nutrient cycling. This is also a buffer zone. So for all this reason, it's important to protect this area. So there is a European directive, the Water Framework, that provides different guidelines in this sense. So it's our duty to develop new approaches and methods to monitor these environmental changes. To do the biomonitoring of an ecosystem, it exists a lot of different clades that can do the job, but in this study we will focus on the Foraminifera clade. Why? Because it's a well-known bioindicator for environmental quality, of course, but this indicator is mostly used in marine environments. So we will try to apply these bioindicators to estuarine ecosystem. So in estuaries, we have a lot of natural and anthropogenic stressors, so we can expect that the alpha diversity will be really low. Indeed, most of the species that can survive this extreme condition are opportunistics. And that's an issue because most of the indices based on Foraminifera were developed in marine ecosystem, and they use this alpha diversity. So they will provide in estuaries bad quality. So that's what we call the estuarine quality paradox. Therefore, our objectives are to develop a new tool using Foraminifera eDNA to see if we can obtain a better assessment of the environmental quality of the estuaries. Just a few words about our experimental design. Our dataset contains 6 French Atlantic coast estuaries. We sampled 22 stations. In each station we took 2 replicates. We did the eDNA metabarcoding with specific primers, and we sequenced with a MySeq platform. We took a different environmental variable like the sediment grind size, the heavy metals, organic carbon, and the climatic dataset. We did a bunch of statistics like RDA and MDS and Venn diagram to evaluate the impact of the different variables on our dataset. I also just want to share a few pictures of the sampling. As you can see, it's quite challenging to sampling mudflat in estuaries, but it's also a very beautiful habitat. When you analyze eDNA dataset, you will have to do the bioinformatics and statistics. And this is a really important step, and you have a lot of issues that you need to deal with, like the management of tag jumping, the low diversity homogeneity artifact, the library preparation, and also how you will demultiplex and prim the trimers of your FASTQ, the clustering algorithms, the assignation tools, of course the statistic interpretation of the data set, and for all these different steps, you will have different strategy. I don't want to go into the details in this presentation, but you will find more information in my YouTube channel, the Protist Words, where you will find this presentation also. Now the results. As you can see here, most of our ISV and read are really well assigned with this huge peak here at 100%. What does it mean is that the database is accurate for intertidal, not flat. And as expected, we have a very low diversity vs fully marine environments. Now let's have a look on the bar plot of the diversity, and as you can see here, each estuaries have different community composition. And for example, the environmental clades, this color here, have different proportion depending on the estuaries. There is much more environmental clades in Ore than in the Laita. And for example, in the Laita, there is some species belonging to Allogromida that doesn't appear that much in other estuaries. If you look on the distribution of the abundant taxa in terms of presence-absence, most of the dominant taxa are present in all the different estuaries. Here we have 16 taxa that are present in all estuaries, and then most of the dominant taxa belong to many estuaries. But there is a huge difference in terms of abundance of these dominant species per estuaries. Of course, you can detect in all estuaries this dominant taxa, but each estuary has its own bench of dominant species. If you build an NMDS with a community matrix, you will see that each estuaries will occupy a different space in the ordination. The Laita and Ode estuaries will not overlap with other estuaries, but for Olne and Elorn and Crack and Ore there is a huge overlap. Why? We can hypothesize this is because they are close from a geographical point of view. And there is potentially some mix of water between these estuaries. So this analysis shows that the advantage of eDNA is to sequence also the propagule and the dormant stage. But one question is now is how do the communities will react to the environmental stressors, the chemical pollution, and also the climate change. To do that, we build an RDA model, and it will provide the significant variables that will influence the community composition. And here, as you can see, there is a percentage of clay, the distance of the sea and the river discharge, and even an heavy metal like the lead here that will influence the community composition, and some climatic data like the isothermality here. But if you look at the percentage of explanation of each axis, it explains a low percentage, 30% for this axis and 13% of this axis, meaning that a lot of variance remain unexplained. If we go a step further in the analysis, we can do a variance partitioning, and as you can see here, the physical and chemical factors will explain about 16% of the variance, and the climatic factor only 8.2% of the variance. So there is this 60% of unexplained variance. And this is an issue if you want to do biomonitoring in the estuaries. The lead, for example, will don't have that much influence in the community composition. So we should think about other factors that will have a major impact on the community composition. So we can make some hypotheses, like the history of the estuaries or the ecological drift. So now it's time to provide a bit of conclusion and perspectives for this study. So there is some limitation with high throughput sequencing, as you cannot assess the active stages. The impact of chemical, physical, and climatic data on the community structure is really low, and the ecological drift could be one of the main drivers of this diversity. But a good thing is that Foraminifera reference database for mudflat is accurate and allows a good representation of the diversity. So with this conclusion, we can say that high-throughput sequencing brings a new vision of the estuarine quality paradox. So my take-home messages will be that with eDNA, we reveal the importance of the propagules and dormant stage in estuarine ecosystem. We also build a promising workflow to study eDNA foraminiferal diversity in intertidal mudflats. But we need a combination of morphological and eDNA approaches to assess all diversity components with the living stage and the dormant and propagules. Finally, I would like to thank a lot the teams that helped me with this project, in particular Marie Fouet, my PhD student, but also Magali Schweitzer, Sophie Kincher, and Franz Joysen. And also, I would like to thank the OFB that provides the funding for the project and you for your attention. Thank you very much.